Hello everyone, I'm Dipali Chandil and I welcome you all over here for the tutorial of word embeddings. So what is word embedding? Word embedding is nothing but numerical representation of words. Now, in this tutorial we're going to discuss about why do we need word embeddings, what are different techniques of word embeddings, that is frequency based and prediction based, then how to train our own word-to-vec model, how to create embedding model using Keras embedding, and how to use pre-trained word-to-vec model. Fine. Now, if we discuss a little bit in detail what is word embedding. So see, every word in word embedding is converted to a n-dimensional vector, and that n-dimensional vector contain a set of numbers, and those set of numbers are nothing but coordinates of the axes of the vector space. Okay. Now, let's see this example over here. So, suppose I have a word age. Okay. Now, my axis, these are my axes. Okay. How many axes we have? 4 axes we have. Fine. Now, let's see. So, what is the vector for it? For this word age, this is the vector. This is originating from origin. Fine. Okay. Now, what are the, how many coordinates will this word age will have? This word age will have 4 coordinates because we have 4 axes in the vector space. Okay. So A, B, C, D, fine. 4 coordinates for the word age. Now, this is its vector length and these are its coordinates. Okay. And these are the axes. Okay. Over here. And this complete is known as vector space. So, word embedding. These coordinates are known as embedding for this word. These coordinates are known as embedding for this word age. Okay, I hope this is clear to you what is word embedding. Now, why do we need word embedding? See, all the ML algorithms and deep learning algorithm can't process strings in their raw forms. Okay, so these algorithms require numbers as input to perform their task. Fine, that's why we need to convert all the words into their embedding. Okay, so that's why word embedding techniques are needed. Fine. Now, moving forward, we have two types of word embedding techniques. So, frequency-based word embedding. So, in this word embedding, these word embeddings work on the basis of the count or frequency of a word in each sentence or document. Okay, and what are its type? Count vectors and TF-IDF Vectorizer. Okay, fine. Now, what is prediction-based word embedding? In this prediction-based word embedding, the models are trained on historical data and it understands the representation of words and their context and placements, okay, in the sentences or in the documents. So when the new word comes, it will give numeric values, that is n-dimensional vector, based on its understanding from the historical data, okay, from the understanding of the context and meaning of the historical words which it learned. Okay, so these kind of models are more useful in real world scenarios as compared to the previous one. Let's take example further to clarify what is prediction based word embedding. Okay, so let's take two sentences. Python is a programming language. And the next sentence is Python is a type of a snake. Okay, so as humans, we can understand the context of the Python words in these two sentences. Okay, first one is talking about the language and the second one is a variety of a snake. Okay, but for machine, this is a challenge to understand the context and the meaning of words. Okay, so this challenge can be resolved by prediction based word embedding techniques in the NLP. Okay, so with the help of prediction based word embedding, we can understand the context of the words which are being used. same words which are being used in different types of scenarios or different types of context. Fine. Okay. Now moving forward, what is count vector? So over here, count vector model, first of all, it learns all the words from all the sentences or documents. Then it models, what does it do? It gives us all the frequencies of, it gives frequencies of all the words which are coming in all the sentences. Now let's see this example over here. We have these two sentences. First sentences, let's say we have two documents, and first document contained this sentence and the second document contained this sentence. The cat sat on the hat, and the second document contained the sentence, the dog ate the cat and the hat. Fine. Now what are the unique words that we can find from these two sentences? These are the unique words. Okay, so how many sentences or documents we have? Two sentences or documents. And how many words we have? 8. That means we have 8 vocab. Fine. Now we will create a table. So this count vectorizer will give us a matrix in the output. Okay. So these are the words that are making as the column names, and these are the documents which are making as the row name. Okay. Now in the first document, that is document 1, da is coming twice. Over here and over here, over here and over here. Okay. Now in the second one, if you see, da is coming thrice, over here, and over here. Fine. Similarly, we can calculate the frequency for all the words in these two documents or sentences. Fine. So over here you can see dog in the document 1, it's coming 0. That means dog didn't came up in the first sentence. Dog is not present in the first sentence. And in the second sentence, dog is there. Fine. So if a word is not present, then 0 will come. Okay. So I hope, like, how does count vectorizer work? This is clear to you. Now let's do the coding part of it. Okay. Now these are some modules that we have to import. After that, these are two sentences, or you can say document. Text and text one are two documents. Now I'm fitting this text, this one, in my count vectorizer. Okay. So first of all, I'm using the count vectorizer class. I'm creating the object of this with the name of vectorizer. With the help of this object, I'm fitting on this document text, fine, which contain this sentence. Now, this created my object for it. Afterward, I want to see the vocabulary which is created with the help of this sentence, with the help of count vectorizer. So what is the vocabulary? You can see over here, it is giving us the word and its frequency. So yeah, not frequency, the word and its index. So M, there, this is word and its index is 0. Now then and is the next word alphabetically, its index is 1. Similarly, next word is by alphabetically arranged data and its index is 2. Then Dipali, its index is 3. Next one is high, its index is 4. And then next one is science, its index is 5. Similarly for the trainer, 6. Now we wanna see for this text. So what does it gonna do? This is text one. Okay. So here we used the fit when we were fitting in the model of the count vector model. Now for looking for the new sentence, okay, we will use the transform function and we will pass the new sentence or new document inside it. Fine. Now let's see what is happening over here. So M has the index 0. Now how many times M is coming in my, as you can see, M is coming twice, over here and over here. So this is for the M. Now next one is end. So end is coming, I guess, just once over here. So this is for the end. Now Dipali is coming just once over here. So this is for the, hold on. Yeah. Okay. So yeah, data is coming. No, how many times data is coming in this this sentence or this document? 0 times. Okay, that's why it is 0. This is for the data, word data. Now, how many times Dipali is coming in this document? Just once. Okay, over here you can see. So it will give you 1. Fine. Now, how many times this one is coming? Hi, over here in this text? 0. Okay, so it is giving you 0. This is for the hi. Then this is for the science. And this is for the trainer. So hi, science and trainer are not, these are not present in the text one. Fine. So I hope this is clear. Okay, now let's take another example to make it more clear. Working of the count vectorizer. Okay. So over here you can see these are my sentences in the list format. Okay, now I'm using this function count vectorizer and I created the object for it. Now with the help of this object I'm fitting this this complete list which has the name corpus with with the help of this object. Okay, vectorizer. Then with the help of this object I want to see all the words, unique words, or you can say all the vocab. Okay, so these are the complete vocab which is this model count vector able to get from these sentences. Fine. Now we want to see this into the data frame format. So from the pandas I'm calling this data frame function and in which I'm passing this is x. Okay, so I'm converting it into the array format with the help of toArray function. Then in the columns parameter I'm passing vectorizer dot get features name, this one. Okay, now in the index parameter I'm passing how many index we gonna have, how many sentences we have over here. We have 4 sentences, so we're gonna have 4 index. Okay, d1, d2, d3, d4. I'm writing these names. Okay, after that this I want to access that data frame, so just I got that data frame like this, as you can see over here. Okay, so let's understand this now. So and how many times and is present in the document 1? 0 times. How many times and is present in the document 2? As you can see over here, 0 times. How many times and is present in the document 3? Once. And how many times and is present in the document 4? 0 times. So you can see 0, 0, 1, 0. Now coming to the word document. So how many times document word is coming in the document sentence 1? Once. In the sentence 2? Twice. And in the sentence 3? 0 times. And in the sentence 4? Once. Similarly, we will get all the frequencies corresponding to all the sentences with the help of count vector. So I hope guys this much was clear to you. So in the next class we're going to understand about TF-IDF Vectorizer. Okay, thank you very much for listening to me.